Welcome to another RSA Security Analytics demo. In this one, we will look at how we can quickly discover web shells operating within our infrastructure and conduct a root cause analysis. First, we need to understand what web shells are. Web shells are code or scripts that are running on a web server, which give remote access to command line utilities or shells. Web shells can have legitimate uses, as much of the software that the Black Hat community uses can. However, these legitimate web shells should not be publicly accessible, as they can be easily found and exploited for nefarious purposes. Additionally, attackers commonly use web shells to further their goals against unsuspecting victims. An attacker will look to exploit vulnerabilities in web applications via remote file inclusion, SQL injection, etc. Once the web shell is dropped on the server, in this case shell.php, the attacker will leverage it to achieve their goals. They will send commands to the web shell, usually via HTTP POST requests. The attacker leverages POST requests because any commands will be sent via HTTP variables and not be visible to traditional SIEMs. Additionally, the commands may be obfuscated via base64 URL encoding. When the commands are sent to the server, they are executed with the same permissions that the web server is running under. Therefore, if the web server was installed with administrator privileges, this script will run as administrator. Now let's look at how Security Analytics provides the greatest visibility into these types of attacks. When we look at the delivery of the initial exploit, network controls in traditional SIEMs give you partial visibility that is based upon signatures. RSA Security Analytics gives you full visibility into the attack by leveraging behavioral analysis of our SIEM, full packet capture, threat intelligence, and endpoint visibility. As we move into the installation phase, traditional SIEM really falls down, and network controls only offer partial visibility. RSA Security Analytics again gives you full visibility into this phase as well. In the final command and control phase, both network controls and traditional SIEM fail to give visibility into data exfiltration, lateral movement, and network disruption. Again, while our competitors fall down, RSA Security Analytics gives you full visibility into the attack by leveraging behavioral analysis of our SIEM, full packet capture, threat intelligence, and endpoint visibility. To see this level of visibility in action, let's move on to a demo of RSA Security Analytics. We will access the system through an HTML5 web interface. Here we can see a dashboard for RSA Security Analytics that gives us some information on the number of current alerts. These dashboards are very configurable and can be set up to your liking and needs. Since the dashboards are HTML5, any portion can be clicked on to jump into an investigation. In this case, we will navigate to our Incident Management console via the menus. Here we can see that we have two alerts, both for possible web shells. If we right-click on the top alert and choose Investigate Events, we will move into the Investigator interface filtered on that specific alert. Now we can see that our behavioral analysis and threat intelligence have identified a potential web shell. RSA Security Analytics found a session where there was a HTTP post with no GET nor a refer. This behavior is indicative of non-human interaction with our web application. So far, we have been leveraging the extensive metadata that RSA Security Analytics generates. But if we want to see the raw data, we can drill into the session represented by the number 2 here. Now we see two sessions where we have indicators of web shells. Let's investigate the top one further. Here, we are looking at the raw HTTP session in text view and can see greater detail of what took place. In looking at the body of what was sent to our server, we can see that the attacker is trying to obtain usernames from the web server by dumping the contents of etc password. Because we have full packet capture, we can see that this command was successful. When we take a look at the second session, we see that the attacker has issued several commands at once, which are a little hard to read in this context. I have copied them out to Notepad to make them more readable. Here we can see the attacker is trying to dump all the user password hashes, zipping them into an encrypted archive called loot.zip. Notice the password in plain text. FTPing the file off to another site, and then deleting all the evidence. Once again, because we have full packet capture, we can see the attacker's actions and the files that he sent. Next, let's look at how we can recover the files that were exfiltrated from our network. First, we will refocus our investigation on the IP address that the files were sent to. Now we see that there is a session to that IP address over port 21, which is potentially FTP traffic. When we open this session, we can see that is in fact FTP traffic and that loot.zip was successfully transferred to the attacker's IP address. To easily recover the files, we can change our view to View Files and see a list of files transferred in this session. Because this is an FTP session, the data transfer is in another session. But by clicking on the file name, we will be taken to that session. This pivot into another session is only possible because of our full packet capture and session reconstruction capabilities. Now, we can download this file, and following safe file handling procedures, so that we don't infect our machine with potential malware, we can open the file using the password we recovered earlier. In looking at the contents of this shadow.txt file from the archive, we can see the attacker successfully stole our passwords from the web server. At this point, we have seen what the attacker accomplished via his web shell, but we have yet to see how he initially broke in. Let's refocus our investigation on his IP address as a source address. Here we can see several sessions over port 80 prior to the FTP data session we already investigated. In opening the first session, we can see a URL encoded string that is indicative of SQL injection, one of the primary attack vectors for installing a web shell. Here is the string decoded and shows the web shell being installed. In this video, we have shown you how quickly RSA Security Analytics can uncover malicious traffic on your network and move to root cause analysis. Thanks for watching.